All right, so today we're going to be diving deep into something I think is absolutely crucial for anyone who's serious about getting into those senior level Java development roles.
Okay.
We're going to be talking about the way interfaces have evolved,
Oh, right. Interesting.
specifically looking at static methods, default methods, and private methods.
Oh, yeah. That's a good one.
You know, when you're prepping for these really tough technical interviews
Mm-hmm.
for senior roles, just knowing these things superficially, it's not going to cut it, you know?
Right.
It's fundamental.
It's definitely a level deeper than just junior level.
Yeah,
You really got to understand it.
it really signals to the interviewer that you get how the language has progressed
For sure.
and how you can like leverage its modern capabilities.
Totally. You need to be able to talk about the why and not just the what.
Right.
For senior engineering positions,
Exactly.
Interviewers are looking for people that can not only write code,
Right.
but understand the underlying principles and the design philosophies of the language.
Uh-huh.
They want to see that you can appreciate how Java has evolved to become more expressive and address the limitations of earlier versions.
Right.
Our goal today is to thoroughly explore static, default, and private interface methods, focusing on why they were introduced and how they're used,
Okay.
how you can effectively use them, and also explain them in an interview setting.
All right. So let's dive right in.
Okay.
Let's start with static methods and interfaces.
Right.
Historically, as many of us who are preparing for these senior roles will remember,
Uh-huh.
interfaces, you know, there used to be these purely abstract blueprints.
Right.
You define the contract, but not the implementation.
Right.
But then all of a sudden, static methods popped up.
Yeah.
What was the thinking there?
Well, I think the main driving force behind that change was the recognition that, an interface represents a core concept within your system.
Right.
And there are naturally utility functions that are closely associated with that concept.
Yeah.
Think about it. Like in the past, if you had a utility function that operated on instances of an interface, you would often end up putting it in a separate helper class, right? Which could lead to some awkward naming conventions,
Right, right.
With static methods directly within the interface, you have a more cohesive and discoverable way to manage these related utilities.
Okay, so it's more self-contained.
It signifies a move toward interfaces being more self-contained units of functionality.
Okay, so give me an example because that makes sense, but how would we actually apply that?
Sure, let's take the example of an in-sequence interface, right?
Okay.
And say it has a static digits of method. You could simply call in-sequence.digits of, let's say, 1729.
Okay.
You get back an object that implements in sequence, and you don't need to worry about the actual implementing class.
Got it.
Like, you wouldn't even need to know about a digit sequence class behind the scenes.
Okay.
It acts as a factory right there on the interface.
So it's almost like you're abstracting away the implementation details even further.
Exactly. This pattern helps to encapsulate the creation logic directly with the abstraction itself.
Okay.
And if we think back to older Java APIs, we used to see a lot of interface companion class pairs,
Uh-huh.
like collection and collections, or
Yeah.
path and paths.
Yeah.
And while those utility classes still have their place, the ability to include static methods directly in interfaces,
Mm-hmm.
it means that this explicit separation isn't always the best approach anymore, especially for, tightly related utility functions.
Okay, I see. So it's about keeping things that are closely related together.
Exactly. And often this leads to cleaner, more maintainable code.
Right. So in an interview setting, I imagine being able to articulate this shift
Yes.
from just purely abstract interfaces to including these concrete utility methods via static methods,
Yeah.
even being able to reference that older pattern of companion classes,
Uh-huh.
really shows you understand like the history and the design rationale of Java.
Exactly. It shows that you've seen these patterns in practice and understand how the language has evolved.
Yeah, and how things have improved.
Right, precisely.
Mhm.
It shows you understand not just the feature itself, but also the problem it was designed to solve
Okay.
and how it fits into the broader evolution of Java.
All right, so we've talked about static methods.
Okay.
Now let's move on to default methods.
Okay, sure.
This one felt like a really big game changer to me in terms of how interfaces can evolve.
Yeah.
So tell me about this default keyword.
All right, so default methods, they were introduced with the default keyword,
Mm-hmm.
and they really changed how interfaces can be extended over time without breaking everything.
Right.
Remember our in-sequence example?
Uh-huh.
We can now add a hasNext method to this interface,
Okay.
and we can provide a default implementation.
All right.
Let's say one that initially just returns true,
Okay.
suggesting a potentially infinite sequence.
All right, so any class that implements that interface, it's going to inherit that method.
Exactly. Any class that already implements in-sequence would inherit this has-next method automatically,
Right.
but it would also have the option to override it if their sequence has a definite end.
Yeah. Okay, that's really useful.
It is. And this flexibility is the core reason behind default methods.
Okay.
It enables interface evolution.
Okay, give me a real-world example of how this would work.
Okay, let's think about the collection interface. It's been around forever.
Yeah.
And it's implemented by tons of classes.
It's everywhere.
Now imagine when Java 8 came out with the stream method.
Okay.
If stream had been a regular abstract method, oh man, it would have been chaos.
Yeah, I can see that.
Every single class implementing collection would have suddenly broken.
It wouldn't compile.
Right. It would lost source compatibility.
Ouch.
It would have been a nightmare for developers, for library maintainers, for everyone.
And it would have gone against the idea of backward compatibility.
Exactly. Java also aims for binary compatibility, meaning that even old compiled code, like JAR files,
Right.
should still be able to run. You could still create instances of older classes. But here's the kicker. If a program then tried to call the stream method on one of those old instances,
Oh, boy.
boom, you get an abstract method error at runtime because the older class didn't actually implement that method.
That's a nasty surprise.
Right.
So default methods came to the rescue.
They did. By making stream a default method in the collection interface, those older classes could still compile even without explicitly implementing stream.
Right.
And more importantly, if the stream method was called on an instance of that older class, it would inherit the default implementation.
Right.
This ensured both source compatibility for existing code and a level of binary compatibility, preventing those widespread runtime errors.
That's brilliant. So it's not just about giving you, like, a way to have optional functionality.
No,
It's actually about a way to evolve those interfaces gracefully.
absolutely. It's a crucial mechanism for allowing interfaces to adapt and grow.
Without forcing everyone to change everything immediately.
Exactly. So for someone in an interview, being able to highlight this impact on backward compatibility is key.
Right, because that's a big concern for large projects and companies.
It is. When interviewers ask about backward compatibility or evolving APIs, you can talk about default methods,
Right.
especially using a real-world example like collection and stream.
Uh-huh.
That shows a very practical and insightful understanding of large-scale Java development.
Right, and it shows that you care about those things, like maintaining a large code base and not breaking things.
Exactly.
All right, so we've got static methods for those utility functions.
Mm-hmm.
We've got default methods for making those interfaces more adaptable.
Yeah.
But what happens when things get a little more complicated?
Okay, I see where you're going with this.
Yeah, let's talk about default method conflicts.
Okay.
So let's say you've got a class
All right.
and it implements two interfaces.
Mhm.
And both of those interfaces define a default method with the same name
Oh, interesting.
and the same parameters.
So you have a conflict.
What happens then?
Well, this creates ambiguity for the compiler.
Yeah.
Let's say we have a person interface with a default getAid method that returns 0.
Okay.
And then we have an identified interface, also with a default getAid, but this one returns the absolute value of the object's hash code.
Right.
Now, if we have an employee class that implements both person and identified, the compiler is going to yell at you.
Yeah, it's going to be like, I don't know what to do.
Exactly. It doesn't know whether an employee's getAid should return 0 or the hash code.
Right. So how do you resolve that?
Well, the employee class is forced to provide its own implementation of the getAid method.
Okay.
Within this new implementation, you have a couple of options. You can define completely new logic for generating an ID, or, and this is the key part, you can delegate to one of the interfaces.
Okay.
And there's special syntax for that. You use interface name .super.method name. So if employee wants to use the default getty from the identified interface, it would look like public NDD, and then in curly braces, return identified.super.getIt.
Oh, that's cool. So it's like you're choosing which parent's behavior you want
That's a good way to think about it.
when you have this sort of multiple inheritance situation.
It gives the compiler explicit instructions. Now, let's look at a slightly different case.
Okay.
What if one interface has a default method, let's say our person interface with its default getId,
Right.
and the other interface, identified, declares on getId method, but doesn't provide a default implementation?
Okay.
Do you think the employee class could just inherit the default from person?
Well, yeah, at first glance, it seems like it should.
Yeah, It's a logical assumption, but the Java designers decided on a stricter approach.
Okay.
Even in this scenario, the compiler will still report a conflict.
Really?
And it will require employee to provide its own getted implementation.
Why is that?
Well, the compiler can't be sure that the default implementation from person actually fulfills the contract of the getAid method as defined in the identified interface.
I see.
Identified might have specific requirements even though it doesn't have a default.
It could have constraints you don't know about.
Right. By forcing the class to implement the method, you're prioritizing clarity and preventing potential bugs that might come up from assuming compatibility.
Okay, so it's safer to be explicit.
It is. It's better to be safe than sorry.
What about if neither of the interfaces provides a default implementation?
Well, in that case, there's no conflict.
Okay,
Employee simply has to implement that method itself.
got it.
Or it has to be declared abstract.
Right, right. And then there's also that tricky situation where a class extends a superclass and implements an interface.
Yeah.
And that interface has a default method that's the same as a method in the superclass.
Right. Another potential conflict.
How's that resolved?
The superclass method always wins.
Okay.
The default method from the interface is ignored.
Okay.
This makes sense because in Java, class inheritance is generally considered a stronger relationship than interface implementation.
So if you're going into a senior level interview,
Yeah.
being able to explain these default method conflict resolutions
Yes.
and why Java handles them the way it does really shows a deep understanding of the inheritance model
It really does.
and the complexities that come up in bigger systems.
Absolutely. Being able to navigate these situations and explain why Java works this way is a big plus for senior candidates.
Right. Okay, so we've covered a lot of ground here with static methods, default methods, and how to handle those conflicts.
Yes.
Now, let's move on to the last part of our evolution of interfaces discussion.
Okay.
Private methods.
All right.
Now, we already touched on the fact that private methods can't be default
Right.
because they can't be overridden.
Uh-huh.
So what's the point of having private methods in interfaces?
Well, private methods, both static and instance, they're basically internal helper methods within an interface.
Okay.
Their main goal is to encourage code reuse and make the logic within the interface's methods more organized.
So it's like cleaning up your code behind the scenes.
Exactly. Think of them as implementation details that are specific to the interface itself.
Okay, can you give me an example?
Let's go back to our int sequence.
Uh-huh.
Imagine it has a bunch of static factory methods, like of with an int as a parameter,
Okay.
or of with two ints, a start and an end,
Mm-hmm.
or of with a variable number of ints using the syntax.
Right, right.
Each of these might need to do some common validation or initialization before creating and returning the int sequence.
Got it.
Instead of repeating that code in every public static of method,
Mm-hmm.
you could make a private static helper method within int sequence that does that shared logic.
Okay, that makes sense.
Each of the public factory methods would then call this private helper.
So you're keeping the interface's public API clean
Yep.
and focused
Exactly.
while handling the internal complexities with those private methods.
It's about maintaining clarity while still having good code organization.
And I imagine in an interview for a senior role,
Mm-hmm.
being able to discuss this kind of good practice,
Yeah.
even within an interface definition,
Mm-hmm.
really shows that you've thought about good software design.
It shows maturity and a thoughtful approach.
Yeah. So to sum everything up, we've covered static methods
Mm-hmm.
for putting utility functions right inside interfaces.
Right.
We've talked about default methods
Mm-hmm.
for allowing interfaces to change over time.
And providing optional implementations.
Right. And we've covered private methods
Uh-huh.
for keeping the interface's code clean and reusable.
Exactly. We've seen how these three features represent a significant evolution in Java interfaces.
Yeah. And they really address the limitations of earlier versions.
They did. And they make code more flexible, robust, and maintainable.
And especially in large, always changing systems.
Absolutely. And for all you folks out there getting ready for those tough senior-level technical interviews,
Mm-hmm.
understanding these features and the reasoning behind them shows a deep comprehension of Java.
Yeah, it shows you can think like a senior engineer.
It does. It shows you can think critically about language features and understand their impact on software design.
And apply them to complex situations.
Exactly, the kind of situations you'll face in senior roles.
So here's a final thought for you all to take away.
Right.
Think about how you could use these interface features, static, default, private methods in your own code,
Mm-hmm.
especially when designing new interfaces or refactoring old ones.
Good point.
And consider how understanding these concepts can help you when you encounter complex systems in your next senior role.
Yeah.
Maybe even spend some time exploring more general interface design patterns in Java.
You might be surprised by what you find.
Exactly. Thanks for joining us for this deep dive.
My pleasure.